All right, everyone, we're back out of here, getting ready to go to the 8-5, 8-6, little graphing quadratics in intercept form, and then comparing quadratic functions to linear and exponential. But before we do, I know the suspense of all you've been waiting for. I don't know if you all remember this. But when we last left off, I told you a story about the ducks. Reggie's patiently keeping an eye on them. We got two in there. They're underneath that heating pan. Probably hear him. Reggie's pumped. He's going to be a duck dad. Come on, Bubby. Check it out. Come on, Reg. Let's go. All right. Had to let you all know that they're good. Nothing to worry about. Here we go. Let's get to it. So graphing quadratics, right? In intercept form. All right. So now I want you to think about this for a second. We got the main characteristics of a quadratic, knowing that we got the vertex, the axis of symmetry. We got all that important stuff that we need when we go to graph it, all right? So we always need the vertex first. We always need the vertex first. We've established this. Now, we could still, and because I'm a beast, we're still going to need the vertex first. However, we're going to find it a little differently. So intercept form is going to be written a little differently as you see it up here. Okay? Now, obviously, vertex form, we can easily find the vertex. In intercept form, we're going to be able to find the intercepts. All right, so this allows us to figure out where the graph crosses the x-axis. All right? Now you'll notice the numbers in place of p and q, right? You see that the equation has the x minus p and the x minus q. For the intercept, it's going to end up being the opposite of that number. So for example, if we have x minus 5, it's really going to be a positive 5 on the x-axis. If we had x plus 3, it would really be a negative 3. All right? So the numbers in place of p and q are going to represent the x-intercepts. All right, where the graph is crossing the x-axis. Now, again, when we go to graph these, let's think about this. We're going to have the intercepts already. We need the vertex. In order for us to get the vertex, we're going to need that axis of symmetry. So to get it, we know, well, if this is where it's crossing the x-axis at, our vertex is going to be right in the middle of those intercepts, right? Directly in the middle. So if I add them and divide by 2, that's going to give me the axis of symmetry, which we've now established. Well, hey, wait a second. That is going to be the x value of the vertex. And then I could just plug it in to the equation to get the y value of the vertex, just like what we've been doing. And then, of course, that number a that could pop up here, a is going to tell us whether it's opening up or down, narrow or wider. All right? So, here we go. Let's take a look at an example together. All right? So we got this function, x plus 2, x minus 3. We're going to graph it. We want the vertex, axis of symmetry, and the x-intercepts. Well, because of this being a plus 2 and this being a minus 3, our x-intercepts are going to be negative 2 and positive 3. All right, because it's a plus, remember we talked about its opposite. Opposite. Those are the x-intercepts, negative 2 and 3. To get the axis of symmetry right in the middle there, add them, divide by 2. If we add them and divide by 2, we get 1/2. If you made it 0.5, it don't matter to me. And our vertex, well, we know the axis of symmetry is our vertex, the x value of the vertex. And then if we plug it in here, back to the original, just like we've been doing, we're going to get negative 6.25. So this is our x and y, or our x-intercepts, our axis of symmetry, and our vertex. All right, remember, we're getting this axis of symmetry from the p plus q divided by 2. Now when we go to graph it, graph should look like what we got here. We got our x-intercepts. Boom, I'm going to plot those. Bang, negative 2, bang, 3. Our vertex, 1/2 and negative 6.25, and then boom, we're drawing a U through them because we know it's a quadratic. All right. Try this one. With the ability of technology, you'll be able to pause. All right. When you do go and graph it, your graph should look like what's there. You have your x and y intercepts because you have the -4 and +1. It's really +4 and -1. When you plug in p plus q divided by 2, you should get 3/2. It's alright if you left it as 1.5. When you plug that to get the vertex here, 1.5 back in for x, you should get this 25/2. 12.5 is also fine as well. Okay? Now, last part of this, the directions may ask you for the zeros, right? What are the zeros of the quadratic? What are the solutions of the quadratic? So what they're really asking for is what are the x-intercepts? The zeros and solutions are the x-intercepts. So how we solve a quadratic, we are getting the x-intercepts, all right? So for example, in our U-try, our solutions are -1 and 4. In our previous example that we tried, our solutions, the zeros, are -2 and 3. Alright, so don't get confused at the directions they ask you for that. It's really all they want. They just didn't know you had a savage teacher like me, just throwing it out there. Alright, and the last part of this, alright, this one kind of goes quick because now we put the whole big picture together, right? Linear, exponential, and quadratic functions. We talked about all three now. So, going through the quick roll call, here we go. How are we going to know which is which? Linear, y equals mx plus b. We know what the slope and y-intercept are. We know that the x and y chart, the y values, we're going to see an adding and subtracting pattern, right? For exponential, we know it's that y equals a times b to the x, where that b is really the growth or decay factor, and it's going to be that curved look. And our x and y, or I'm sorry, our y values will be having a multiplying and dividing pattern. And now we've established that for a quadratic, it's going to be that u, that curve. It's written in that y equals ax squared plus bx plus c. It could also be written in vertex form. It could also be written in intercept form. But we know that our x and y chart, the y values will mirror each other. They will be the same once we approach that vertex from one side to the other. So when we're comparing them, we're going to need to refer to those three things. What's the formula, right? What form is it written in? What's the graph look like? And then what's our x and y chart doing? So like for example, if we had these two x and y charts here, well, this one, I'm looking at the y values. I know that the pattern, right, looks like it's being +1, +1, +1. That's telling me because it's plus 1, that it's linear. The pattern's plus 1, we know it's linear. These over here, if I'm looking, it looks like they're dividing by 2. Divide by 2. Divide by 2. Division. I know division. That's going to be exponential. It's an exponential function. Alright? If they mirrored 3, 2, 1, 2, 3, they're mirroring each other. We know that that's going to be a quadratic. Alright? And again, this is exponential, so we know the graph is that curved type graph. We know linear, it's a straight line. Quadratic is that U. Alright? Hope this is helping. As always, don't hesitate to reach out to me, everybody. I'm here. Keep grinding. Awesome job. You know where to find me if you need help. Hope you guys are healthy and safe.